Alright, this video is going to be a little bit of a lesson on quadratics, and we're going to take a look at solving and talking about the pieces of quadratic, identifying the parts. So, the first big thing is we're going to talk about quadratic itself. You know it's a U-shaped curve, goes like this, unless it's got a negative in front of the x squared and then it flips upside down. Biggest key piece right here is the turning point. Also, the biggest thing is known as the vertex. You also hear us say it's the turning point. It is, in this case, going to be a min, so a minimum, because it's at the bottom of the U. If it's the top and an upside down U, it will be a maximum. And we want to talk else about the y-intercept would be where this thing, the parabola, hits the y-axis. So there's your y-axis, there's parabola, so where they hit, that's the y-intercept. Where it hits the x-intercept are the more important things. Those are also called zeros. So make sure you write that down under zeros here. You will hear them called the x-intercepts, but zeros are the main thing. You also hear them called solutions like they have right here. The other thing I like to call them are roots. It's a huge name for them. Solutions not as much, because that's more for when two things intercept, but it will be called solutions sometimes. Zeros and roots are the better answers for those x-intercepts, okay? And we need to talk also about the axis of symmetry. That's the line that comes right down the middle here. You do have a formula for it. It's called x equals negative b over 2a. That's your formula. And you can get the b and the 2a from your equation. If you have it in y equals ax squared plus bx plus c form, you can quickly pull out the a and the b and use this formula. You also might remember that it's always a vertical line, so it has to be x equals, and all we need is this coordinate right here. So if you look at it, it's 0.1, negative 4. So what's the key point? The x is worth 1, so my axis of symmetry is x equals 1. It's a vertical line coming right down here on the 1. Okay, those are pieces out of the quadratic. We're going to go and explore and talk a lot more about that today and how to deal with this unit on quadratics. Now, when it comes in terms of solutions, there are three types of solutions here. This is the typical one right here. How many times does this parabola cross the x-axis? And you should be able to identify 1, 2. So this is the typical picture where there would be two solutions. And that's going to happen 90-some% of the time. Two solutions, okay, in most of the cases the parabola goes across. What happens in this one right here, in the second one? Does it ever hit the x-axis? No. So what do you think the answer is? No solution. Has none, okay? So they say no solution to that one. And finally, the last one hits right at 1 point, so you have one solution. Those are the three types. If you're just talking a quadratic by yourself, only graphing them, you can get 0, 1, or 2 solutions. Okay, moving on. Okay, so we're going to talk about how to solve and find the roots. Well, one method, of course, is called graphing here. And when you're going to graph, it says what it says. You put the equation into y equals form, throw it in your graphing calculator, graph it, and then what do we have to see? Well, we have to see where it hits the x-axis. So hits or intersects the x-axis. So hits x-axis. Okay, and that we just talked about on the previous page, getting 0, 1, or 2 solutions is a possibility when you got a quadratic, because it's x squared, you can have up to 2 solutions. All right, then there's also the table. If I got it in the graphing calculator, we can put it in the table, or take a look at the table. And under the table, you're going to go under, and you're going to find where the value of y is 0. So look for the zeros. Oops, sorry, look for the zeros on the y1 going down that table. Okay, the x values are your roots. I can squeeze that in here. Yours probably has more room in my paper. They condensed it all in here. So those are your roots. So once again, those are your solutions, your roots, your y-intercepts, your 0 or or x-intercepts or zeros, okay? So graphically, you can throw it in the calculator and you can find it either by graphing or you can hit the table. They also didn't say the fact you could also find the zeros if you go to second trace again. Second trace, and one of your choices under there will be for the zeros. So don't forget that on your calculator is another option, and you move the spider close and hit enter, enter, enter. All right. Now, obviously, sometimes we got to find stuff by hand, and they don't want you to use the graphing method. So we've got a few of those. We've got factoring, okay? Set them equal to 0, and then factor into two sets of factors. This should just look like two sets. I got them combined on two lines, so one and then another. So I'll draw it down here. You'll get 1 times the other, set equal to 0. And then, like I said, tee it up. We always teed it up once we have the equations and find out what x equals and x equals, okay? You may be using the AC method, so I guess make that note. AC method and comes involved in there with the X box. Depends what method you use for factoring, okay? That's one method. Then a second method is the quadratic formula. Sometimes factoring doesn't work, so we go to the old quadratic formula. Right here it is, negative b plus or minus square root of b squared minus 4ac all over 2a. Once again, you're setting it equal to 0. You have to identify your a, your b, and your c, and you use the quadratic formula. Definitely will work every time. Factoring is limited how many times you'll do it. Calculator doesn't give you a nice perfect answer, although with the second trace thing option I talked about, you can find pretty close to it, but not necessarily exact. Round it off if that's what they want on decimal. Quadratic formula does work. And then the last one we need to talk about on the next page, besides quadratic formula, gives you another option. So let's talk about the final option. Final option, you should remember, complete the square. We did a lot of this, and you can do it to find just the vertex, you can use it to find all the shifts, and you can use it to solve. So the first thing they said basically is move the c to the other side of the equal sign, take half the b. I like to write it below, remember, right after you do take half the b, I like to write it right under that equation so I'm set and I don't have to think in a minute. And then you square it and add it to both sides. Rewrite the left side as a perfect square, x plus or minus that half b. If you'd already written the b down, you just put an x plus in front of it, put it in parentheses and square it. And that equals the c, which actually turns out to be the negative c on the other side. And then you had added a half of b squared, whatever half b was, that was squared. So that combines just a single term on the other side. Then what happens is you've got something in this form. You got an x plus, let's say, something, whatever. I'm just going to put a garbage, whatever there. Square, I don't care what that is. Equals some number. Whatever that might be. Okay, and then what you have to do is take the square root of both sides. Remember, when you take the square root, it's plus or minus. Let's pretend we got x plus 3 equals plus or minus square root of 7 or something like that. And then your last step, just move the 3 over. Do not move it under the thing. You cannot combine it with the square root of 7. So you would get something like x equals negative 3 plus or minus square root of 7. If the 7 or something like that was a nice number, like square root of 4, and you can pull out a 2, then sure, you can do negative 3 plus 2 and negative 3 minus 2. You can combine them. If they ask you the nearest decimal, you can put it on the calculator, okay? All depends what they want. The only reason why you would bring this whole thing back over and not the c, instead of bringing this, you move over for solving, bring this over to this side, is if you were looking for, like they say, the vertex or the shifts, okay? Otherwise, keep that stuff on that side, follow that process. We're going to practice them in school tomorrow, all these methods again, because we got to be able to solve quadratics. Have a good evening.